Well, the next car we're going to pick on for a low, a rough idle and a P0171 and 174 is a 2007 Sierra. There's the truck, and we've got DTCs of P0174 in the freeze frame, and we have a failure record for a 174 and a 171. So we're setting this code for both banks. Take a look at the data as we go on a test drive. What we're doing here is graphing the data from a Tech 2 into this piece of software that allows us to display it in a nice graph and be able to move a cursor around and choose different scan data PIDs to overlay. What I want to point out to you is that the amount of time in this window is 160 seconds. So we go take the engine, and we start out at idle here. The technician raises the engine RPM to 3,000, and then he takes it and does a pretty good wide open throttle accel. So what I'd like to use is that engine speed to make a comparison to some other PIDs. So let's change this this PID here to the mass airflow sensor. So that's overlaid with engine speed. So as you can see right here, we're at idle, and then the technician revs the engine up. We don't get that big a change in mass airflow sensor. That's pretty normal. But then here, he's actually putting the engine under load. And finally, when we get to our wide open throttle pull, if we get right to the top of that, we're getting about 230 grams per second out of the mass airflow sensor, which is plenty good for this engine, and really is kind of showing us the mass airflow sensor is probably in good shape. So we've got our mass airflow sensor and our engine speed there. I'd like to change the bottom PID here, and let's take a look at the load PID. And this is the engine load. Engine load is a calculation that each manufacturer can do the way they want to. In this particular case, this load PID is really not a volumetric efficiency PID. It's a cylinder filling PID. So as soon as the technician pops his throttle open, the load goes to 100%. And if I change this this PID on the bottom here to the APP, you get a pretty good idea that that's the load PID. Once you get it to wide open throttle, is going to be at 100%. Under other conditions, where the throttle is not as far open, the load PID has a different value. And now we'll continue and keep changing that PID. I want to see what's going on with the intake manifold pressure. If we look at our idle intake manifold pressure, we've got an intake manifold pressure. Now this isn't MAP, this is intake manifold pressure. So if anybody was to think in kilopascals and take a vacuum gauge and stick it on this truck, you would have a kilopascal reading at idle of 60. And in my mind, that's high. I think this truck has low manifold vacuum. It's not a it's not a make or break deal, but it's a clue as far as I'm concerned to where the problem might be. We continue on, and I want to take a look and compare the oxygen sensor. One thing I notice here is when we're at idle, the oxygen sensor's flatline at low voltage. When we accelerate, the good news is the oxygen sensor is at 900 millivolts. So that's telling us that our fuel control system seems to be working under load conditions and off idle. And then we come back to an idle period here, and the oxygen sensor flattens out again. We switch over and look at the other bank. Let's see, the bank sensor 1, there's sensor 2 for bank 2. And now we'll take a look at short term. And this to me is showing that here we are at idle. As soon as we get to idle, a short term starts climbing up until it gets up to 28% to keep this thing running at idle. The short term on bank 2 is doing the same thing. The long term has learned to do this particular change, so you got a 29% add that's been learned for idle. When we're under load, the long term is at it comes here. I'm sorry, comes closer to 0. And then finally, I want to do a total fuel trim PID, which adds up all the fuel trim. And you can see that when you're under load, the fuel trim is basically spot on. But when you're in an idle condition, overall, this truck's adding between the both banks, adding it all together is adding 57% fuel. So, it's a pretty clear-cut idle problem. This problem happens at idle. And of course, most of you at this point are probably already thinking, hey, where's the vacuum leak? And that's what's wrong. Basically what we did was we just took it for a little ride. We took our scan data. We analyzed what we were seeing, and it helped us to determine that the problem was happening at idle. It was not happening any other time. So it really lets you focus your attention